Hello and welcome to NCO presentation. My ID number is 22CS083 and my topic is Flynn's classification. So let's start.
So there are three total classification in computer architecture. First of all, first is Flynn's classification 1966. It is based on the multiplicity of instruction stream and data streams in the computer system. So what is meant by instruction stream and data streams? We will discuss further in this video. As examples of Flynn's classification is SISD, SIMD, MISD, and MIMD. Second one is Fang's classification, 1972. It is based on serial versus parallel processing. WSBS, WPBS, WSBP, and WPBS. Here, W means word, and B means bit, and S means serial, and P means parallel. Third one is Handler's classification, 1977. It is determined by the degree of parallelism and pipelining in various subsystem level. PCU means process control unit, ALU means arithmetic logic unit, and BLC means bit level circuit. So what is meant by Flynn classification? Flynn classification is the most popular taxonomy of computer architecture proposed by Michael J. Flynn in 1966 based on number of instructions and data. It is based on the notion of a stream of information, two type of information flow into the processor. What is meant by stream? Stream is basically, it is known as kind of flow. Instructions and data. The instruction stream is defined as the sequence of instructions executed by the processing unit, and the data stream is defined as the sequence of data including inputs, partial or temporary results called by the instruction stream. So basically there are four types of the Flynn's classification. According to Flynn's classification, either of the instruction or data streams can be single or multiple. The computer architecture can be classified into four categories: single instruction stream, single data stream, single instruction stream, multiple data stream, multiple instruction stream, single data stream, and multiple instruction stream and multiple data stream. In this diagram, you can show that single, multiple in instruction and data stream. So there are four classification of Flynn's taxonomy. So there are different uses and different applications of these four types. The first type is SISD computers. An SISD computing system is a uniprocessor machine which is capable of executing a single instruction operating on a single data stream. Single instruction means only one instruction stream is being acted on by the CPU during any one clock cycle. And single data means only one data stream is being used as uh, input during any one clock cycle. Conventional single processor, one human computer are classified as SISD systems. It is serial means non-parallel computers. Instructions are executed sequentially but may be overlapped in their execution stages. Most SISD uniprocessor systems are pipeline. What is meant by pipeline? Pipelining is a process of storing and prioritizing computer instructions that the processor executes. SISD computers may have more than one functional units, all under the supervision of control unit. Examples of SISD computer is most PCs, single CPU workstations, many computers, main frameworks, CDC 6600 and VAX 11, IBM 7001 are SISD computers. In this diagram, you can show that there are single instruction and single data. We are working with single instruction and single data. Then that is called as SISD computer. So that is an example of SISD computer. First of all, we take load A, load B, and addition of that and store into C, store C, and A equals to B into 2 and store A. So at a time, a single instruction and single data are passing and evaluating that. Then we are called as a SISD computer. Second type is SIMD computers. An SIMD system is capable of executing the same instruction on all the CPUs but operating on different data stream. Single instruction means all processing unit executes the same instruction at any given clock cycle, and multiple data means each processing unit can operate on a different data element. SIMD computer has single control unit which issues one instruction at a time, but it has multiple ALUs processing units to carry out on multiple data sets simultaneously. Well suited to scientific computing since they involve lots of vector and matrix operations. Example, array processor and vector pipelines. Array processor means I double L I A C I V M double P. Vector pipelines means IBM 9000 Cray XMP YMP and C90. So you can show that there are single instruction, but we are working with multiple data, then that is called as SIMD computer. So there are this example, we can show that there are single instructions are there, but we are working with multiple data. There are we perform the we perform same operation on multiple data, then that is called as a single instruction multiple data. Third type is MISD computers. In MISD, multiple instructions operate on single data stream. And MISD computing system is capable of executing different instruction on different PUs, but all of them operating on the same data set. Multiple instruction means each processing unit may be executing a different instruction stream, and single data means every processing unit can operate on same data element. Machines built using MISD model are practically not useful in most of the application. A few machines are built, but none of them are available commercially. Example, systolic, systolic arrays. And that type of the computers are not practically or commercially available in practical, but that is a theory. Or you we can say we can show that in the diagram there are the multiple instruction, but we are working with the same data element. So that is the example of MISD. We are working with single data, but there are multiple instructions are there. You can sort that in P1, A1, A1 and into 1, and then P in P2 into 2 and Pn into n. So there are multiple instructions, but we are working with A1, yani ki single data. Then that is called as MISD. Fourth type of the computers is MIMD computers. An MIMD system, it is capable of executing multiple instructions on multiple data sets. Multiple instruction means every processor may be executing a different instruction stream. Multiple data means every processor may be working with the different data stream. MIMD systems are parallel computer capable of processing several programs simultaneously. Can be categorized as loosely coupled or tightly coupled depending on sharing of data control. So what is mean by loosely coupled? Processor has separate memory, and tightly coupled means processor has same memory access. So example of MIMD computers is most current supercomputers, network parallel compute grids, and multiprocessor SMP computers, including some type of PCs, IBM 370, Cray 2, Cray XMP, CMMP, VEC 1 1180. So that is the type of the MIMD computers. So we can say that we are working with multiple instruction with multiple data, then that is called as MIMD computers. So we can say that we can show that in the figure, in example we can show that we are working with different data and different instruction. So that is called as MIMD, multiple instruction multiple data. So we discuss about four types of Flyn's classification. So thank you for watching this video.